Good morning, everybody. Welcome back to another strategic farming Let's Talk Crop session. Today, we decided to tackle the topic of drones in row crop agriculture. And we really wanted it to be a wide-ranging discussion, so not focusing on an individual subject within the use of drones. And so uh, here with us today, we've got two guests that are going to help us kind of address that topic. And so I'm just going to take a second to introduce them before we recognize our sponsors. But from the Iowa State Digital Ag Innovation Lab, we've got Ryan Huffman. He's a senior research manager. And we also have Jorden Kuntz, who is founder of Biosphere Drone Solutions. So they're going to be on the show today to kind of help kick the topic off and then help facilitate the discussion as we move forward. But I do have to thank our sponsors today, Extension, as well as Minnesota Soybean Research and Promotion Council and the Minnesota Corn Research and Promotion Council. With that, I think we're going to get started here. And I think plan is here, Ryan, you are going to kind of kick things off.
So I want to take a couple of seconds just to introduce who we are. Not everyone may be familiar with the Digital Ag Innovation Lab at Iowa State. So very similar to all the things that probably happen at the University of Minnesota, we have a very similar mission as well. So that includes innovation, education, and outreach. Really, the innovation is the research that we do every day with our industry sponsors. The education component is really focused at our undergraduate and graduate students that we have come through our program, as well as upskilling industry professionals. As we all know, technology moves extremely fast and it's hard to stay up to date with it sometimes. And so there's industry folks that we also kind of bring up to speed as we learn some of the newer technologies coming to market. And then the last one is outreach, which is, today's a great example of that. How can we continue to share knowledge that we may have with others and then learn from others because we are also not the source of the entire knowledge base in this space. So I'm happy to share today with Jorden because he brings a lot of knowledge that I don't have on drones from a technical perspective. So what we do, as I mentioned, is industry-focused research. We have a list of some companies on the right that we work with. This is by no means an inclusive list, but we are really focused on getting products to market. So if you try to do a Google Scholar search of anybody in our organization, you're probably going to struggle to find a very high publication count from anybody within our org due to the fact that we're focused on like the products, like I said, and getting intellectual property into the hands of our sponsors and out to industry. So enough background on that. I always like to start topics around drones to just level set to make sure that everyone kind of has the same fundamental understanding of remote sensing. So the first thing when you hear drones, you probably think of imagery drones. And more times than not, what we're doing with imagery drones is using different wavelengths to understand crop health, for example. So here are some grossly simplified cartoon depictions of what essentially happens in a row crop production field. You have on the left here red, green, and blue wavelengths. And you can see that the red and blue are absorbed into the mesophyll. The reason it's that cell layer particularly is that is where chlorophyll is housed. And we know that chlorophyll is where photosynthesis occurs. And green is primarily reflected, which is why you see healthy plants showing a green color or pigment to them. And then there's this fourth band that we're always interested in, which is infrared. And that primarily penetrates a little bit further into the profile of the leaf tissue and is also reflected similar to green. And so really what the figure on the right is trying to show here is that as the plant health changes, or maybe as the plant senesces, the amount of energy that's either absorbed or reflected changes, and that's where we get a lot of the plant health indices that you're probably familiar with or at least heard about to some extent. So here is a cornfield, just using basic RGB imagery, and you get a bird's eye view using a drone that, 10 years ago when drones were just coming to market, we never had, right? Depending on how tall you are, that was about the highest viewpoint that you could get. from the field that you were trying to grow a crop on, or you had a research trial on, or maybe you were scouting for a customer of yours, whatever the case may be. And the main takeaway here is that you can learn quite a bit of things just having a bird's eye view of your field of interest, right? Uh, Minnesota is very much like Iowa in the terms that we get some heavy torrential downpour rains, and unfortunately, some ponds start to occur. And then you can also see on the left and the right side, those headlands are pretty beat up, and there's not a great crop stand there. So you can learn a little bit more from an aerial view of drones, which is really why, 10 or so years ago, they became extremely popular. And then when you think about that infrared band that I talked about, and for those of you needing a little bit of a refresher on the electromagnetic spectrum, there's a little summary here in the bottom left corner. So shorter wavelengths are higher in energy, where longer wavelengths are lower in energy. The visible light spectrum that we always talk about, that red, green, blue, that lives at about 400 to 750 nanometers. And then the near infrared region is just outside of that. Technically, it's about 750 to 2500, but it's really 750 to 1000 or so that we tend to be interested in for the most part. And so if you look at that same field here under an infrared wavelength, where again, that is primarily being reflected, not absorbed into that crop canopy, you get a whole nother level of perspective on your field, right? You can see that those ponds have a little bit bigger of a footprint than maybe you initially thought there was. And you can see kind of all those scatter marks throughout the figure where maybe the planter was plugging or having difficulties. And then you can really see how bad those headlands actually are. And the reason that this is important is because you can generate really nice NDVI figures, or normalized difference vegetation index. This is something that has just really flooded the market over the last 10 to 15 years, and whether it's satellite imagery or drones, is probably the most common plant health indice that exists. So by merging those two maps that I just showed you together, you get something that looks like this. And what this also looks like would be a yield map. So now, let's say it's about June, maybe it's a little bit later in Minnesota, just to the later planting. You start to get a preview of what your yield map for this field could look like. And the reason that's important, and the reason drones have been widely adopted, is we have the opportunity to do something about this, right? We have the opportunity to maybe go replant some of those areas and recover some stand if there's time left in the growing season. Or maybe it's apply a fungicide if there's a lot of disease outbreak. We don't have to accept this at face value and go into harvest knowing that 25% of that field is a loss, for example. And so when we talk about other things that drones can do, I would say, going through like an evolutional history, that was probably the first one. Plant stands has become something widely adopted in recent years, and a lot of even egg retail companies and seed companies leverage this technology because on the left is probably something many of you have done in your time, walking across a cornfield or a soybean field, measuring out in corn that 17.5 foot stretch, doing the plant counts, multiplying it by 1,000 because it's 1/1000th of an acre. As the summer goes on and you get hot, tired, sweaty, your job quality maybe goes down a little bit. Afternoon data may not be as good as morning data just because of normal afternoon kind of tired and everything that comes in after the lunch hour. So drones allow us to maximize the amount of stand counts that we can generate to the degree of either a half-acre grid all the way up to 10 acres if you're not looking for a very high-resolution map. That's something that's automated now and allows a single person to cover a lot more acres with much more efficiency because of the technology that's come to market. Weed mapping is a second one. There is a huge interest in the industry right now around precision spraying. There's several companies that have put machines to market that can either in real time detect weeds and spray them, or through a mapping procedure similar to what's shown on the screen, you can generate a prescription map from. So this image is essentially a unplanted field. You can tell that it's later in the springtime because it's got an NIR filter on it, and everything that is green is reflecting in this kind of magenta color. So presumably everything you're seeing within that blue field boundary would be a weed because we've yet to plant the cash crop that is intended for this field. And you can learn a lot from this that doesn't require a lot of fancy technologies or even initial investment in the drone of use here. So weed mapping has become another widely leveraged resource that drones can offer growers if they're looking to reduce their chemical footprint as well as maximizing ROI. And at Digital Egg, we are very much a production mindset. So you probably saw a few of the companies noted on that initial slide that we work with are equipment manufacturers. So when we think about crop production, it's everything from planting to harvest and how the prior growing season impacts the next growing season. And so here using just RGB with a very simple drone that's maybe less than $3,000 to $4,000, you can see on the left, this is a soybean field right after harvest in the fall of 2024. You can see the different striations, the different spread patterns that happened. You can see a lot of start-stop events. Presumably, a lot of issues happened in this field where maybe the grower was rushing to get that crop out ahead of a rainstorm or whatever the event may be. And you don't think much about it until the following year when you go to plant the next corn crop. And you can see there's a lot of similarities between where the biomass is high versus where it's low in relation to the prior soybean spread pattern. And so you start to understand if you're the grower, you did everything right. You planted at an optimal time, you had a really high fertility program, you had a really good herbicide with a good burn down and residual, but yet you still saw implications. That was a carryover effect from 2024. And so drones give us another layer of information in our toolbox to understand where we went wrong and how we can correct that moving forward. So that's a quick summary on imagery drones, just to kind of get us thinking about drones early here on a Wednesday morning. Spray drones are the next extremely hot topic and probably even hotter topic just because of how fast they've came to market in the last 3 or so years. So this is a field day that I'm sure you guys have either attended or host yourselves up north. This was in Northwest Iowa last year that we got about 40 individuals and 3 different companies out to just showcase what the different OEMs can do and the kind of the pros and cons of each drone, just to let people know if this is something they're interested in or maybe even interested in purchasing and getting one of these up in the air themselves. So you might be wondering, why spray drones? I think any of us that are technology enthusiasts don't really ask that questions. It's more of how we can deploy them and where's the most optimal conditions. So pretty simply, it's operation on saturated fields. So you look at that field in the upper right corner. Even if you take that pond out of it, it's going to be quite some time before you can get a 50,000-pound sprayer across that field to do any type of post-herbicide application. Drones would allow you to get out there this day if you really were excited about spraying weeds and there was a crunch in your timeline, that would allow that to happen. On a related note, you put more control and power into the grower's hands to dictate when an application can be done. So if you're someone that leverages a local co-op or a neighbor that's a custom applicator, you're really at their timeline and their schedule on when they may get to your field. A drone allows you to bypass that and get your application done when you believe it's optimal for your field. And on the bottom left is a image of a crop duster. And this would be a field that crop dusters would prefer to stay out of for some pretty obvious reasons. There's a lot of aerial obstructions nearby. You see tall trees, you see power lines. It doesn't appear to be that large of a field spatially in terms of acre count. And so this would be a field that they would more than happily give up to a spray drone operator so they could go operate on something that's a little bit more free of obstructions. So there's a disclaimer on the bottom right, and I did some investigation. So the Iowa has what's called the Iowa Agricultural Aviation Association. It's a very active and great group to work with. We've got involved with them in the recent years to just integrate drones and how it fits into their community. And Minnesota also has the same, and both of them roll up into a national organization. So I would encourage, if you're not a member or have not heard of them, to at least look into what Minnesota has to offer. Because at least in Iowa, they're very welcoming of the spray drone industry to, again, make sure that we are not only safe in the same airspace, but also effectively covering as many acres as efficiently as we can. And then the last bullet point there is just really a reason for spray drones around the precision spot spraying and the dry product applications. So not only can you put wet product on, you can also put a dry hopper on and do cover crops or dry fertilizer or anything related to that nature. So two slides left, have some data associated with them that we as an industry are really starting to wrap our heads around. So when you think about spray drones and all the things that we can control on them in terms of getting the highest efficacy possible, there's a short list here on the left. So what is the application rate? If the drone has nozzles, what different nozzles are maybe ideal? Some drones use atomizers, so that one has an asterisk because it may not actually be something that we can play around with. The speed of the drone, the application height of it, understanding is deeper canopy penetration better, or is it more in corn, for example, do we really just want to focus on the ear leaf and above? I'm not sure there's been enough research to suggest that deeper canopy penetration is got a negative effect, but there's not really anything saying it has a positive effect. So just something we as a industry need to focus on. And then the last one is swath width and overlap. So you can see the figure on the right here that the University of Missouri put out last year. They looked at a few of those different parameters and how fine-tuning some of them either can increase or decrease the coverage percentage that they were seeing. And this was in a soybean field that they were using water-sensitive spray cards to document what that coverage may be. And it was interesting to see, most of these top few outside of the this bar, 3 gallons per acre at 10-foot height at 26 feet per second. Most of those are more or less the same coverage, which is, sub 20%. And it was not until you get towards the bottom of this figure that you can see things in the 25 to 60% coverage. And so you might be wondering, well, how does that relate to where we are as an industry today? So they took it this one step further and did this same study comparing it against a John Deere 4830 ground sprayer. And so right out of the gate, a lot of people in the industry have been struggling with just the overall reduction in the application rate. And what does that mean for efficacy of our products? What does that mean for coverage in general and just overall productivity in that field that I'm looking to deploy this technology in? So you can see that the test parameters on the upper left of the figure in terms of the different gallons per acre, the application heights, and the speed at which those machines moved across the field. So ground sprayers are the black bar, which is that John Deere bar. And you can see for the most part across that 100-foot swath, somewhere between 30 and 35% coverage on average. Drones, to get that same 100-foot swath, you're going to have to make 3 passes. And so that's why you see this multimodal distribution of those yellow bars. But it's definitely below 15%. And I would say the average is probably closer to 10% coverage. What was interesting, the result from this study was that they saw no difference in weed kill rates, even though there's a large difference in coverage and application rates. And so that's a really positive output for the industry, but also shows that we just need a lot more research in this space to continue to get people comfortable with drone technology and where and when it can be leveraged. So that is everything in terms of slides that I had, Ryan, just to kind of set the stage and warm up the group for some conversation here and make sure that we're kind of all at least on a level playing field with initial kind of knowledge here.
Okay, well, thank you. And we would welcome any questions. We don't have any in the current Q&A, but if anything was sparked in your interest, make sure you enter those into that box for us. Jordan, I know you were going to share a couple of things. Did you want to start with any sort of presentation, or do you want to wait a little bit when we get into discussion around cover crops?
No, I was working more with Ryan on this. I mean, most of the stuff that I would cover kind of touches with what Ryan was going over. I mean, majority of the data that people really are focused on is what he's hitting on here is the coverage side and just what the efficacy is of drones in spraying or with cover crops as well too. The only things that I had, to add on a little bit, and we can jump back into Ryan's presentation quick, and I had just something I could add if you want to.
Sure.
I believe it was the second to last slide. Right, there you go. So one thing I just want to touch on here, Ryan, and you kind of hit the home bases there, is you were saying there's different nozzle selections, and I do want to kind of give a little background on that, as far as the drone side where we come from. So starting out, with the drones when they first came out, being produced, the goal was to kind of replicate a ground sprayer. And so the nozzle started out with a pressurized system, is what they were seeing, which became very difficult with your spray patterns. And so when you look at, a flat spray or a cone spray on a pressurized nozzle, so, for existence, like a T-Jet brand nozzle, the hard part is getting that spray pattern from that nozzle directly underneath of your props. So the goal is using the prop wash, the down pressure from the air of the props to push that chemical down into the plant. And that's what we're using to kind of sort of mix it and cover all over the leaves. So, on a ground sprayer, how we usually explain it is the more water you have, that's what you're using for your coverage. You're using, if it's 15 gallons an acre or 20 gallons an acre, you're using that to essentially get coverage across the plant. On a drone, you're using air with droplets that are smaller. So what they changed, and you can see this in the picture on the slide there of the DJI drone. It's a T40. So there's only two nozzles on that drone, and they're based right underneath the props. And the little head on there is a motor, and it's got a disc on it. And what that does is the water is actually just supplied to it. It's not pressured anymore. So they took out the whole pressurized system, which allows us to really focus on the droplet itself. There's a disc on there that kind of looks like a spinner spreader, but for liquid. And the reason for this is they call it a centrifugal nozzle. But the faster that disc will spin, it actually will slice those droplets. And so the faster it spins, the smaller the droplet gets. And the slower it spins, obviously, the larger it gets. So this allows us to change our droplet size while we're flying. So on the go. So out spraying, there's so many variables that, whether it's wind speed, the product you're applying, if you're not seeing the coverage that you're wanting, all of that, and the products that we're applying too, if you're swapping products midday, you don't have to worry about swapping out nozzles across your whole sprayer. On these, there's just two nozzles, and in the controller itself, you can then select what size of droplet that you'd like, which helps us tremendously. If you're flying and you're seeing you have a really small droplet size for micron size, and you decide that it's not getting the coverage on the leaves that you're hoping to, it's kind of floating, in the wind a little bit, the breeze picked up. We can drop that to a bigger droplet size, which would be a little bit heavier. It'll give down to the plant a little bit better. So all of that, then obviously looking at the data here takes into effect as your spray width and pattern. But that's something that allows farmers to kind of customize their spraying based off of what product they're applying or what the conditions are outside.
So let's dig into this topic a little bit more. So, good points with how this kind of platform works for herbicide spraying. Now, of interest here is we had a webinar earlier in the season on targeted spray from a ground perspective, right? The different technologies that are available for a ground rig to use kind of targeted herbicide spraying. How does the drone fit in that world? Are there similarities or I don't know, just maybe make a comparison for us?
Sure, absolutely. So, and this is a very common question for us that we get. And my background really helps. I came from the precision ag world, working on GPS and auto guidance work, as well as sprayers. So, looking at a drone, your goal was efficiency at the beginning. So you're going down to 2 gallons an acre, just like an airplane is, but you're still getting the same effective rate for your spray as a ground rig would be. So a lot of these studies that companies are doing, I know a lot of seed companies are doing studies on this now to see, if you spray like Ryan's slide was showing, as far as coverage goes, if you're spraying, 15 or 20 gallons an acre versus 2 gallons an acre with a drone, you know, are your yields going to come out the same? What we're seeing on data is it's either the same, if not slightly better. But a lot of that comes down to, you still have, root damage, that sort of thing from compaction of the ground sprayer because it is heavy. And so that's where the drone, obviously aerial helps. Now looking at ground sprayers, getting into the technology of actually spot spraying individual plants. Me personally, I don't believe that drones will make that step anytime recent or soon, because looking at sensors and how timely they are, right? On a ground sprayer, you might be going 10 miles an hour through a field. Most likely on those sensors, you'll be going more like 7 miles an hour, kind of like a combine would. So going through, it's got a split second to make that decision to spray that plant, and it's spraying a very small spot. Drones are made to spray, essentially the larger the area, the better, to get better coverage across all plants. We're mainly, I mean, drones really stepped in on the fungicide side where you want full coverage on everything. The hard part about getting to spraying individual plants from a drone is you have so much variability in position based off of whether it be wind or something like that. The drone can fluctuate in the angle that it's flying in the air. So if you have a crosswind that comes up or a little gust that comes up, that drone's going to flare a little bit to compensate for it. Now, on a ground sprayer with those sensors, and I came from the GPS world with auto steer, if that sensor gets off by a half a second or a second, your whole calibration is off now. So for your steering side, you could be off 2 or 3 inches. If you have satellite drift on a drone, if you're looking at that, I mean, you get off by 1 second, now you just missed that whole plant and you wasted that product on the ground. So I think that's why there's been a lot of hesitation on the drone side of not going to that point of spraying individual plants. We focus very much on getting just full coverage across the plant and using a lot less gallons per acre at a more of a concentrated rate. Is you're saving a lot of liquid still, but you're also still getting the same yield.
So another question for you, I guess, then is full coverage is better, but are any of the companies out there trying to integrate, say, weed mapping imagery with the drone application? Because there might be a way to make your drone application more efficacious if we've, slowed down or decreased our swath width. I don't know, like do
Sure.
something to kind of target these areas that might have higher weed pressure.
Yeah. So, like companies like DJI, which makes the T40 in that picture there, that's who we deal with, primarily on our drones. They have the Mavic 3 multispectral. And so kind of as Ryan was touching on before with your NDVI imagery, they also have the NDRE imagery in there as well for sensors. And so, I mean, you have a whole broadband spectrum there, but that's really going to what helps you with that chlorophyll content of seeing that as the NDR imagery on those sensors. Now, the reason why they went with a smaller drone is just for coverage of acres. So, with a T40, you're going to have a lot less smaller flight time because you have a large drone in the air. It's a lot of capacity to carry, even at a small tank. So with an empty tank, you're still probably 15 minutes of flight time. You get to the Mavic series with those sensors on there, you can cover 300, 400 acres pretty easily. And your drone's going to have a flight time of about 40, 45 minutes.
Excellent. So, a couple of questions then around kind of the logistics here, or maybe even the legal side of things. Like, well, what's it cost to get into spray drone? If I'm looking at trying to do herbicide, maybe multi-use, herbicide, fungicide, insecticide, that sort of thing. And does
Sure.
it vary if I just want to go one way or the other?
Yeah, absolutely. So, there's and Ryan can touch on this some too if he has some, but because you guys are going through this process too, but depending on what you're looking to do, right? There's different ways. So customers can go in personal if they're doing their own personal acres. A full drone setup, just the drone, charger, batteries, that side of things, you're about 35,000, 36,000 for a full setup. Right now through, we sell DJI drones, so that's a T50. Um, there's a lot of other brands out there. Now you got to look at, how are you gonna essentially tote that product around to go and spray? What are you gonna spray off of for a trailer, to be portable? So, I mean, I would say a lot of farmers that we deal with aren't looking for the huge trailer rigs. They want just a simple top deck. We build drone trailers as well, so a majority of the farmers we deal with end up buying trailers through us. Trailer wise, you're looking probably around 40,000 for a trailer setup. So you're 75,000 for a simple drone, one drone with one trailer setup. Then you got to add on a generator, so 15,000 watt generator. You can pick those up, 2,500 bucks, a couple grand. So I would say all in with tanks and pumps, you're probably around 80 to 85,000 full setup for a farmer. Now, if you're going commercial, you're going to look at 2 to 3 drones. Your trailer setup's going to be a little more exquisite. I would say you're probably looking roughly, 150,000 for everything. You got a bigger diesel generator. It's more efficient to run all day long. Can power more drone chargers. Your trailer's going to have everything like our trailers have the platforms on top that fold out, so you have more landing space for multiple drones. We put a lot into our trailers for the commercial side. And then you're going to have, tanks, larger tanks, inductor cones for mixing, product tanks, and more likely an injection system for your chemical.
Yeah,
Uh,
and maybe I'll just touch on the flip side of that. So Jorden hit on kind of all things spray drones. On the imagery drone side, a Mavic 3M, M stands for multispectral. You can probably, well, if you can get one right now, it's a little difficult to get one, but if you can find one, you could probably pick it up for less than $5,000. And then you're not going to need as many batteries. You may not have to worry about the generator if you're not planning on flying a whole lot. But the one thing that you will likely want is some form of software package to stitch and analyze the imagery that you do collect. So there's the whole world of just flying the drone and collecting imagery, but then you also need to think about what am I going to do with it now that I have it sitting on an SD card? So the cost entry there is substantially lower than spray drones. And, the, I guess, message that I probably didn't hit on overly well in that slide deck was there's a lot you can learn from drones, even at that $5,000 entry. A basic RGB package, if you want to get one that has a couple of different NIR filters on it or multispectral bands. Still going to be in that sub 5,000 range, but there's a lot that you can learn and do in terms of managing your crop for a fairly low investment.
So you mentioned the software aspect of it. Now, you have software you could purchase, and then you maybe could have a service that you could use. Do those vary in their costs? And like, if I was starting with this, which way would I go? Would I go the software route, or would I go the service route, or maybe compare and contrast those two avenues?
Yeah, I'll start and maybe see what Jorden has to add in here. I would say it's really dependent on what your comfort level is out of the gate. If you are interested in it, but maybe don't feel that you fully understand a software package or don't want to learn it, then I would go a service route where you rely on somebody to do that. There's several companies that you can just upload your imagery to, and they will stitch it in a matter of hours, and they'll provide you those maps back, whether it's NDVI or any of the other indices that you're after. And those you could, spend a couple $1,000s pretty quickly there. If you choose to purchase a software, you can probably get that for a few $100s, but then that requires that you have a computer that can process that imagery. And we've done it before where it almost sounds like our laptops are like a Boeing 747 and you're thinking it's getting ready for takeoff, but it's just working really hard. And we probably should increase our CPUs there. So again, fairly small investment, but primarily it's what's your comfort level. If that's something you want to take on, or would you just prefer out of the gate to maybe outsource that to some other third-party company?
Yeah, so I 100% agree. I mean, there's a whole spectrum of softwares that are out there, and companies that already process for you too. Like Ryan was saying, I think a good level to start at is to have somebody else processing the data for you to help you learn. You can start analyzing those maps. So as you start, if let's say you're flying the Mavic 3 multispectral, which we can get now. Thankfully, there was a period there where it was hard to get them. But it was actually it does take a lot to process its images and to learn that data, right, of how to read those maps from multispectral imagery. So, taking that imagery to a company that processes it to start out with is really nice because then when you get the results back, you can almost use that as like a test form, right? I mean, you can kind of challenge yourself to try and learn it, but at the same time, you can justify what your answers were and see if you were right as to how you were, looking at it. We've had a lot of customers start out with that way. I think there's a big market there, whether you're just a farmer that wants to get into better crop management, to get in and have a company read them for you, and then start understanding what's actually going on in your fields. And like Ryan said, it can be a pretty inexpensive investment for you and your farm to do something like that. And then there's also the option for commercial use. A lot of younger students that I know that get out of college that have agronomy knowledge, they can read those maps to a level. They start out doing that. They'll do some flights. It just gets them in front of more farmers and customers to kind of understand what's going on in their fields. We've seen it a lot where to get going in the market because it's a hard subject for farmers to understand what these drones are capable of. And so they'll do the first flight for free. They'll fly the field and show them the data. And we've rarely will have a negative response to that because farmers love to see that data and how they can improve their crops.
Oh, good. So we're going to kind of stay on this imagery thread right now. So I've got a comment question here talking about NDVI maps and that they mimic yield maps quite closely. And the question then is, what decisions can be made with an NDVI that cannot be made with the yield map? So what does the NDVI kind of provide, I guess, over the yield map?
Yeah, so our mindset with that is it gives you targeted areas to go investigate. So, technology is great, but sometimes it's hard to really reproduce the human component of it. And so, if you know that there's spots of your field that you want to go lay eyes on to understand truthfully what's going on there, it gives you a little bit, for example, that was an 80-acre field that I showed. You probably don't want to spend all day in 6-foot tall corn walking an 80-acre field, but if you know exactly where you're going to go because there's a problem, it gives you less time in field to understand, is that a nutrient deficiency? Is that an insect outbreak? What's truly going on there? But the biggest thing is that piece of information in season. Yield maps, it's October, November, and you have no way to influence that crop at any point other than try to make adjustments into the next growing season. So that's the big difference in our eyes is you have the ability to mitigate whatever issue is going on there and try to recover some of that yield loss that's projected.
So along the same line, then there are some services that offer NDVI image use with just a standard RGB camera. And so is that just as effective as using a more powerful multi-spectral camera when you're generating this NDVI data?
Yeah, so with the basic RGB camera, you can generate what they call a Vary map. That doesn't require the use of a infrared filter or band. Those are similar in nature, like those maps will look fairly similar, but the resolution and the scale is often different between the two. So if you're looking for kind of a rough and quick and dirty approach to what does plant health look like, you certainly could go the RGB route to generate an indice like Vary, VARI is how that's spelled. But if you're looking for a little bit more precise and actionable insights, I would probably not leverage that.
Oh, excellent. Um, so for someone that's looking to get started in this, what do they have to be concerned with sort of the regulations, licensing, insurance, that sort of thing, to kind of make the jump? And you
Right.
might want to split that into, just imagery use versus spray drone use and, where those two things kind of come together.
Sure. Well, I can start with that one, Ryan. And as far as, flying a drone for commercial use, your first step is always getting your 107 license. So it's a commercial drone license through the FAA. That side can be done through a testing center that's local to you. The FAA has what they call the drone zone online on their website that they go through, and you can set up an account. You can register a drone through there, and then you go through and start booking an actual test for yourself. And they do now have actual knowledge booklets on there for you to go through and study with. So that way you can actually see, what's all going to be in the exam. The great part about the exam is it helps you understand aeronautical maps and patterns. So being just aware of airports and how they function. I think there's a miscommunication there. Some people getting that exam will say, well, it's only for pilots with airplanes. That's where it's heavily focused on. But I think the part that we're missing is that we need to understand what the pilots with airplanes that are going through and how they function with airports, so that way when we're flying near one, we know, one, how to communicate with the tower, control tower, with your drone, because you will have to call in, and two, just knowing, if for some instance you were ever near an airplane, what pattern they're going to take and where you should and shouldn't be flying around there. So to start with would be that 107 license. I believe I know for when I took it last, it was 175 bucks to take the test, and that was you take it once and pass, and if you don't pass, it's every take is that 175 bucks. You just reschedule and go again. So
Okay. And then I imagine from state to state, things are going to vary quite a bit when we get into pesticide applications. So it's probably best to, wherever you're at, contact your state Department of Agriculture or whoever regulates pesticide applications to figure out that licensing scenario, because it gets complicated. I know that. So, um, kind of along that line, there is some question about use of non-American made drones. I know that's been in the news a few times. Do you guys want to address that situation, or do we know much about it in terms of where that's all at?
yeah, so we get this question all the time. Obviously selling DJI drones, they're Chinese made. And I think there's been a lot of attempts to, they see the drone ban on social media, online. It's definitely something that changes so rapidly that it's hard to stay on top of with every single moment. But as far as things are going, the initial push of banning Chinese drones, because it wasn't just DJI, it's essentially any drone that's Chinese. They're looking at trying to control more of the data they're taking. So I think the initial push was that they were tied with the Chinese military. They obviously knew that that wasn't true, so that's why it got kicked off the ballot so fast. Um, in any of those instances, if you look at the legislation, they do state in there that if you already own the drone, it's already in the U.S., then they would not be able to ban it if it ever was passed. That's essentially grandfathered in, so you'd still have control of that drone, be able to utilize it on your farm. They won't ground it. It would just be the banning of importing new drones from Chinese manufacturers.
Excellent. So we did have a comment, one applicator here from Minnesota indicating that you can add this drone aerial application with your private license here for individual farmers doing their own applications. So just make that mention. Also, you have another viewer that said that you have to do an FAA medical exam before you take this test, and the viewer indicates they found out they had or higher blood pressure and then failed the exam. So it took several months in terms of a delay to get their license. So just kind of interesting couple comments there from folks that are tuned in today. Here we
I
got
jump in
another.
there quick,
Oh,
Ryan. So that would be on the part 137, the spray drone side. You'll need a class 2 medical exemption, I believe it is. Or
okay.
maybe it's class 3. Don't quote me on what class that is, but he is accurate on that statement. So we as a university just went through that process. So Iowa State as a entire entity has the ability to fly a spray drone through our 137 waiver. What we heard through the lawyer that helped us through that process was that they're looking to waive that. That was a carryover from a manned pilot requirement, which makes complete sense that I would want anybody, flying a manned aircraft with several hundred passengers in it to be medically cleared. But they have found, and they being the FAA, have found that that's probably a little bit too much for a remote pilot in command or a drone pilot on the ground. So there is hopes that that actually will get knocked off the list here, potentially even in 2025.
Okay. Let's see here. One last question with the imagery before we kind of switch gears. What format multispectral images, what do they usually come in terms of file type? And what software do you typically use for analysis? And I know there's lots of options, but what are you guys kind of seeing is what you use, or maybe what would be good for a beginner? Just an opinion here more than because clearly there's lots of options.
Yeah,
Yep.
so I'll touch on this briefly, Ryan, and then I'll let you go because I'm sure you've dealt with more of the different softwares that are available. Um, us as a dealer for DJI does have some software that is capable of processing some of this through their Smart Farm series online. And so using like the Mavic 3 multispectral, we normally deal with that. But then again, you are, going through that software, you are the one that's deciphering what that data shows through those sensors. And so all that's going to replicate then is taking all the images that that drone takes, and they're just going to essentially stitch them all together and build you a map of your field. So, but then you still have to go from sensor to sensor and decipher what that's actually showing, whether it's, insect pressure, weed pressure, a fungus, or, whatever it could be.
Yeah, so generally those images come out as JPEGs, and then like Jordan was referring to, they're stitched together, and so there's a lot of factors that come into play there. That's probably a whole separate discussion, but it gets into how much overlap you want and how many images are going to be taken per flight to understand what your true file size will be there. But for the most part, those images are individually exported as JPEGs. And then we have leveraged Pix4D quite a bit lately. We've also used Drone Deploy in the past. And then also as research always goes in these weird corner use cases, Esri, that people are probably familiar with, has a drone to map, which is an open source platform that doesn't cost anything, but you have to understand kind of scripting and GIS platforms quite a bit. So we've done quite a few things in that platform as well, just really nailing down precisely what these few plants, even within a field, maybe score on a plant health indice rather than like the whole field collectively.
Excellent. So we are going to switch gears a little bit. So we're going to start talking about application of drones in terms of cover crops. And so a few different questions here. Uh, Maybe first compare or contrast, if you know, the sort of conventional seeding versus the no-till drone type application of seeding cover crop, if you've done any work or know of any work in that arena.
Yeah, so last year, last fall, we had the opportunity to work with Dubuque County, where we're at here in Iowa. We did about 8,300 acres of cover crops in the county. And so, which was a fantastic opportunity for some of our pilots to even get in on it. Um, so we did three different mixes. We had a premium mix, a winter kill, and straight rye. And we gave farmers opportunity to pick, which one they wanted on their ground. This was all through NRCS. So it was, funded. Um, but through that, we had different application rates for each product. And they chose it depending on their ground. Now we were a lot hillier here. The biggest push and why guys are really starting to draw towards cover crops with drones is because of timing wise. So we started August 10th. We were done by October 10th. So it was a pretty quick application for 8,300 acres. We had several pilots out applying at the same time. But the general consensus was that they have a lot more applicants than this year to go through the same process to consider adding cover crops to their farm. And it's small amounts. I mean, 80 to 100 acres on a farm, but each farmer gets kind of then see what that can do for their soil health or their next year's crop. So, but we put majority of it in before the corn or soybeans were even harvested, and a lot of that comes down to timing to make sure it gets in, so that way it's not too tall for your beans, so that way you're not going through two crops at the same time. Um, but as far as the corn goes, we didn't have any complaints last year on either one of having it applied beforehand. It would give it a nice shot because we did have some moisture at that point while crops was still standing for us to get in there, get the seed in, and then the moisture was able to bring it in um, to help it germinate before they harvested.
Okay. And then as far as experience with different cover crop species, either single or blends, are there things that you've learned as far as things that are going to have better success over other choices, I guess?
Yeah, that's a really hard thing to answer, mostly because it depends on your soil type and the year that you have. Some seeds will handle, drought better than others, or heavy rains better than others. If we have, a lot of rain in the fall, which hasn't been likely lately. Like last year, we had a drought, and so we it was a pretty good mixture of fields depending on where you were at. We had a few rains, but um, I would say, I mean, all of our mixtures tended to do well as long as we got rain last year. Um, it really depends on soil type too, though, and what your ground is like if you have a lot of residue. So I do know that the ground that we got in before harvest, if the seed hadn't germinated yet, having that residue from the combine come over top of it and hold moisture did help it germinate later on. That was an interesting thing to see. Um, but all in all, I mean, it's a varies heavily depending on your weather and your soil.
Okay. And I suppose the other big factor there is what's your goal with your cover crop too, because I know we hear oftentimes that's sort of the big issue is, what am I after as far as using a cover crop? So, okay, good to hear. I didn't know there was one question here. Oh, there we go. What's the range of and weight that can be carried in a dry hopper on a drone? So they're wondering about the kind of payload aspect of dry products in a drone application.
Right. So, like the DJI T50, biggest one that DJI makes, you're looking about 120, 125 pounds of seed, to be putting in the hopper. So, realistically, most likely you're applying maybe 3 acres at a time, is covering. Your swath width's going to be about 25 feet, 24, 25 feet in there. And that's flying about 12 and a half to 14 feet above the crop.
Okay, excellent. And then we've got a couple of questions related kind of more to using imagery. And the first question is about insects and determining or finding insect feeding damage with leaves that are maybe throughout the canopy and how that might work. And then there's another question related to imagery and using it in terms of end sensing. So kind of take those in whatever order you want, and that'll get us through our questions that came in ahead of time. So,
Yeah, I'll tackle the feeding one. So today it's very difficult to understand like where in that canopy the feeding is occurring. So that's kind of a futuristic, aspiration for remote sensing to get to that point, and that's probably where humans are still going to be the gold standard today. But what you can do is, again, using just basic RGB imagery, you can continually monitor a field and look at those green pixels. And so what that does is it gives you a proxy in your field of how much green biomass is there. And if you start to see a decline in that or a degradation in that profile, you would likely assume there's something feeding on it. You can go out and confirm that, with your eyes and put boots on the ground type of an approach. But that's kind of the current status today of where like feeding or insect damage can kind of be monitored is just more of the degradation that you can see remotely and overall biomass. And then the nitrogen sensing one is more so on a software limitation and modeling side today. So to understand that, tissue sampling is really the gold standard, right? You need to go out in the field, grab tissue samples in different areas of the field that represent maybe where you could be deficient or sufficient, submit those to a lab for analysis. And say on a young corn crop, 3 to 5% is probably that range you're hoping to see that report to come back in. And anything, below that would suggest you're a little bit deficient in nitrogen. So there's models out there today that have been trained to, show a figure like I had on the screen earlier that you can get, within 80% accuracy of what a tissue sample could be. That's going to be representative of your whole field. The resolution of that is a little bit to be improved upon. You're talking maybe like 10 by 30 foot grid sizes, which aren't overly large, but they're not extremely small at the same time, which is way better, back to the stand count topic, than, 5 to 10 tissue samples per field is probably the most anybody's going to grab just because they're getting tired of getting cut by corn leaves and walking through a field in the hot, humid summer. So we're definitely advancing what we can do in terms of estimating the nitrogen content in a field remotely there.
and I suppose one of the major challenges with nitrogen is when that crop really picks up its demand, and when you start to see the uptake happen, and when are you taking your images, and it can kind of create all sorts of challenges, I guess. Let's see here. One last question, then we got to call it quits. So I know we got a couple more coming in here, but any experience working with contact herbicides with the drone application platform? Those are typically herbicides we're going to use higher carrier volumes, really require great coverage in order to see good results. And if you do, what kind of adjuvants are you using?
Gotcha. So I guess I'll start this one out, Ryan. You can finish it if you want. It becomes difficult with drones, right? There's a lot of liability to using herbicides with a drone. So we usually recommend with customers that, stick to the label. The label allows you to do airborne application. That's why the EPA controls that. So if it does have a label created for aerial application, stick to that application rate. But the other part of it is the drones are becoming more advanced to the point where you can use them for contact herbicides, right? I mean, the ability to change your droplet size to a larger droplet becomes very useful, as well as, the software's kind of tailoring towards it now. So, a big part of it is spraying fence lines around a field. They have the abilities now where the drone can do what they call the boundary only pass, where it flies just outside of the field. And use only the outside nozzle. So you'll fly a lot lower to the ground to get a small spray spot. And then you'll just use one nozzle instead of two. It'll be the outside nozzle to fly just that fence line and just spray your inside or the edge rows, essentially your headlands. So there's abilities to use that technology to tailor towards the contact herbicides to control, your weed pressure on the outsides. but it just comes down to there's a lot of liability, and make sure that you're using the product properly.
Well, excellent. I think that covered things real well. Thanks, guys, for participating today and helping with the discussion. Really appreciate it. Also want to thank Extension as well as the Minnesota Soybean Research and Promotion Council and Minnesota Corn Research and Promotion Council. And thanks, everyone, today.